Hello and welcome to the Our Connected World podcast, brought to you by TE Connectivity. I'm your host, Michelle Dawn Mooney. Today we're talking about unleashing a new era of smart manufacturing. Discrete, hybrid, and process automation technologies are transforming production. With these technologies, manufacturers can achieve unprecedented economies of scale with vast customization opportunities and optimal maintenance predictability. There is still much to be done to achieve the full potential. Today, we will look at how industrial engineers can bridge this technical gap and develop new architectures enabling smarter machines across the factory floors. And we've got two great guests for this conversation today. Dr. Anil Kumar Ramshesh is Fellow Industrial Business Unit at TE Connectivity, and Ivan Ruiz Stubel is Senior Manager, Global Product Management, Industrial Business Unit for TE Connectivity. Thank you both for being with me today.
Thank you.
Thank you, Michelle.
Looking forward to getting into this conversation. Before we do, can I ask you to give a brief bio if you can? Ivan, starting with you.
Well, again, thanks, Michelle. As you mentioned, my name is Ivan Ruiz Stubel, and I work as a Senior Manager, Global Product Management in TE's Industrial Business Unit. I basically lead product strategy and execution for industrial communications for products that include but aren't limited to single-pair Ethernet or SPE, circular and rectangular connectors. I have approximately 20 years of very diverse experience from the industrial automation, oilfield services, mining and metals, and pharmaceutical sectors. And from an academic perspective, my background is on first industrial engineering, then business administration, and last but not least, computer science.
And Anil, what about you?
Thank you, Michelle. I'm Dr. Anil Kumar, Fellow in Industrial BUT Connectivity. At 30, we are 14 fellows. We focus on next generation technology and innovation and talent development and solving customer problem. So I'm in TE past 2 years. So earlier to TE, I have worked in multiple industries like sensors, automation, and industrial equipments. So my experience, totally I have around 40 plus years of experience. Academically, I have done my PhD in instrumentation and basically electrical electronics engineer.
So clearly both of you know what you're talking about, and you're the perfect guest for this conversation today. And we do have a lot to get to because there are some amazing changes that we are seeing that are affecting manufacturing. So where do we start? Let's start with you, Ivan. How do virtual PLCs and other controllers enable manufacturers to develop and then run more flexible and decentralized production processes?
Great. Thanks, Michelle, for the question. So virtual PLCs, they rely on virtual machines or containers to run a virtual controller inside a powerful piece of hardware. And currently, they're revolutionizing the manufacturing industry by enabling flexible and decentralized production processes. So again, unlike traditional PLCs, which often require physical hardware upgrades to perform new functions, virtual PLCs can be adjusted through mere software configurations, enabling motion control, image recognition, and many other functions. Moreover, they can run on various hardware platforms, including industrial PCs, local servers, and in certain use cases, even cloud-based platforms. And this provides manufacturers with a full array of choices to meet their needs. And again, being able to run in different hardware configurations, it's a key driver of decentralization and decentralized control. For instance, virtual PLCs can be deployed at the edge of production processes, reducing latency and improving real-time decision-making, while more process-intensive data operations like time series database process can be deployed at the cloud. Moreover, these type of units, which are high-speed Ethernet native, can operate autonomously or in coordination with other units, enhancing overall production flexibility. And again, lastly, PLCs, in certain cases, are even hardware agnostic. And because of this, they minimize the need for dedicated hardware units, reducing initial capital investment. This makes it more affordable to upgrade and expand production capabilities to industrial end users.
So, Anil, Everything is becoming smart. And that's a lot of our conversation today because technology is changing. We've got smartphones and smart cars, and we're talking about how manufacturing can get smarter. So how are smart industrial production machines similar to and then different from conventional manufacturing machinery?
Yeah, thank you, Michelle. Let me start with saying smart industrial production system as a factory of future. So why do we say that factory of future? So generally, if you see with the increasing demand of the customer requirement, and on the other side, we need to have an affordable, effective, efficient manufacturing process, and also we need to maintain the sustainability aspect. Means we should have a green and clean factory, and most important thing is on the safety of the manufacturing. That is one of the critical things. So the smart industrial production or factory of future will help us in achieving these things. So let me take in a little more detail into this. So if we have a modular and adaptable system and solution which is flexible, convertible, reusable, and expandable and combinable, then the benefit there comes the reduction of the capex. So we are putting up a plant. So now I can reuse the components, and then the cost of investment goes less. If that product line is we are end of the product line, we can reuse the system and configure it for the new thing. This will also help in doing it faster, saves time in establishing the new lines, and enables sustainability, as I mentioned earlier. In the traditional system, it is a dedicated manufacturing line for a particular product, and it is designed to do a particular process, which may be customized for that product, which is customized for that product. While the smart manufacturing system is configurable with stations that perform generic performance like process like punching, cutting, welding, those kind of things, and it is integrated to meet the requirement of a particular product manufacturing. These stations could be reused in the other product lines also.
And we hear more and more about robots. They have been used for a while in manufacturing, but it's really at another level now. So how is robotic automation enabling manufacturers to develop and run more flexible and decentralized production processes?
Well, this is a great question. So first, what I would like to clarify it's that robots are a very broad category that encompasses automated guided vehicles, AGVs, collaborative robots, Cobots to articulated robots. There is a whole universe of different robots. But the key aspects of modern robots is that they can be reprogrammed for various tasks. And this reduces the need for specialized machinery at the automation end user side. This flexibility basically allows manufacturers to quickly switch production lines to accommodate different products or variations with minimal downtime. So again, for instance, Cobots or collaborative robots, they can efficiently handle custom orders and small batch production. These robots are being deployed across a wide range of industries, from electronic manufacturing to metalworking. And in these cases, for instance, the operator can quickly train the Cobot by mimicking a manual operation, such as welding, allowing the robot to execute the task with minimal programming needed. And lastly, what I would like to clarify is that with the massive adoption at the advent of artificial intelligence, machine learning, and vision recognition technologies, robots can improve performance over time, adapting to new tasks and optimizing production processes. Leveraging this strength, robots can, alongside humans, combine their strength to increase the overall efficiency and safety within production processes.
You mentioned the word adapting, and Anil, there's a lot of adaptation here because we have all of the new technology, but you can't just drop it in. It's not plug and play, right? We have to have some work done beforehand. So what are the challenges in developing the required technical architectures for leveraging factory robots on today's factory floor?
No doubt, to design a flexible modular manufacturing system, one should have a broader understanding of multiple domains and benefits what we get from that multiple domains. The second thing is integration of multiple product or systems together. Interface between the things, it is very important to understand and take it forward. The second point I say about is the standardization of the hardware, software, communication protocol, etc. We need to plan it. Especially the connectivity solutions becomes very critical there, because now when we want to interchange, the interfaces should be reusable and easy to do it, and there should be flawless interface. So that is the most important. The connectivity and communication solution for such system, we at TE Connectivity, we are working to support our customers.
And Neil, as a follow-up to that, what would you say is driving market adoption and demand for robots, and what could limit this?
Yeah, the flexibility, what Ivan was mentioning, and adaptability and reconfigurability is the one which is driving. The second thing is productivity. So it could be faster, quicker, and also creating an environment of safety and taking it forward. The challenge I see here is in today's market demand, variants of the product is more. There are multiple variants of the product that come in. So manufacturing different variant would be always a challenge if you have a traditional line. But if you have a robotic thing, we could configure for different variant the same system, and we can use it and make the production economically feasible, adaptable to various requirements.
So I would think there's a pretty big learning curve here, because this technology is coming at us so quickly and there's a need to adapt. We've heard that adaptability and adaptation come up a few times in this podcast already. So given that this is a very early stage of development and that the technologies are undergoing constant iteration, how reliable are these technological architectures, especially in improving the operational durability required for always-on production?
Well, these new technology architectures incorporate redundancy, fail-safe, and advanced monitoring tools that enhances robustness and operational durability. Predictive maintenance and remote management techniques further ensure smoother and longer-lasting operations by addressing a couple of issues proactively. It's also worth noting that new technologies like virtualization are playing a crucial role in improving reliability and reducing costs. Virtualization allows to simulate environment, for instance, in digital twins, in which manufacturer can test new configurations without disrupting actual production lines, minimizing risk and physical resource use. Virtual platforms, on the other hand, allow for rapid prototyping and scalable testing, enabling thorough evaluation of various scenarios quickly and inexpensively. And this process also supports collaboration among geographically dispersed teams, leveraging AI and machine learning to optimize configurations and ultimately predict performance. So again, overall, iterative development, predictive maintenance, and virtualization collectively are enhancing reliability of early-stage manufacturing technologies, ensure that they meet the demands of always-on production while keeping the costs low.
Anil, how is modularity changing traditional thinking about machine operation on the factory floor?
Yeah, let me take an example and start here. There are certain few common things between the traditional and modular manufacturing system. Like the material what we use, generally the raw materials like steel, aluminum, plastic, resins remains largely same. Of course, with some exceptional like new composites or new alloys and those kind of a thing. But when we want to process that, way we process, that is the mechanical engineering aspect of physics and chemistry related to that, still need to be handled in the same way as we do it in the traditional thing. But we can do it in a better way using this modular system and approach. In the entire process of the entire value chain, we can do it in a different way to get the benefit. But with the advancement with IT, sensing technology, data collection, data archival and analysis, and enabling this enables modular and smart manufacturing unit, leading to better safety and efficient operation. Like example, Ivan was mentioning about digital twin. Today, we don't need to establish a pilot plant to do the analysis of the flow. It could be done virtually using the digital twin on a machine, and we could configure it, and fairly you can get a better accuracy, maybe around 90% or 85% plus accurate real life information you can get, and you can run and take it forward. So this helps in way of thinking or how we design. It is in a different way. That is one thing. For instance, the preventive maintenance of the plant. Earlier, we never had that opportunity to do that because of lack of technology. Today, yes, we can do that. And to do that, we need to think, can we do that? Someone should know, and they should be able to enable it and take it forward and do that. So while designing, we need to have a broader thinking, how it could be used, what it could be. And as I mentioned, the digital twin would help us for easy and fast changeover of the production lines, and also early estimation. If there is something that is going wrong, we can early predict it and take it forward. So that is the benefit of putting the modular system over traditional system. But to do this, we need to have a larger understanding of what is that enables to do all this and what best we can do it.
So what would you say is enabling the transition toward interoperability, specifically around the design of machines and the components used?
Yeah, let me take an example now. Connectivity solution. That's our domain. I would like to explain it. So if I have a multiple protocols and if I have a multiple connectors, mechanical connectors to connect the thing, it would be quite challenging. I can't do it faster. So at TE, we are working on the solutions that could make our customer easy to connect and configure it. So like one of the things that we talk about is single pair Ethernet. Probably Yvonne would speak more about that. So where the communication and power is on the single line, and that helps just plug and play in the mechanical connection. That helps in plug and play for different modules or different stations. So that's how we are trying to help our customers.
So, Yvonne, what is TE doing to help manufacturers develop the technical architectures they need to convey data and power flexibility throughout a decentralized system?
This is a very good question. And again, Anil mentioned a lot of relevant points. And at TE, we believe that industrial automation is facing a pivotal moment as numerous advancements are converging to redefine the automation landscape. Innovations in miniaturization, artificial intelligence, and increased processing power, among other factors, are poised to drive significant transformation in automation throughout the coming years. TE is at the forefront of this evolution, working on a broad array of technologies, including interface connectors, board signal connectors, switching, isolation, and passive components, among many, many others. These efforts aim to enable and support the next wave of automation, fostering a more efficient, intelligent, and integrated industrial ecosystems. But among all of these technologies, the line that threads through the fabric of industrial automation is single-pair Ethernet. Single-pair Ethernet, or SPE, brings cost-effective, efficient, and robust data and power transmission solutions over the same cable. Its simple cabling reduces weight and space requirements, supporting longer runs and providing sufficient bandwidth for various applications. Again, some examples. SPE's ability to deliver both data and power over a single pair of wires simplifies installation and maintenance, which is crucial to power IoT devices like sensors and actuators. One thing that I would like to highlight is that this type of technologies, it's designed for harsh industrial environments. SPE enhances reliability with improved electromagnetic interference immunity, and it facilitates unified network architectures, simplifying management and scalability, supporting advanced technologies like edge computing and real-time analytics. By enabling smart manufacturing and Industry 4.0 principles, SPE ensures efficient resource utilization and, as Anil was mentioning, predictive maintenance, making it essential for the next generation of industrial automation.
Anil, I'm going to throw it back to you. What other types of elements, such as the power grid, are affecting broader use of factory robotics?
Yeah, in traditional manufacturing unit, generally we used to have AC motors, depending on the capacity and the size of the plant and the product we manufacture. But today, when you look at in this modular thing, since things are modularized, largely DC motors have been used. So if you look at, there are multiple power conversions that happen, AC to DC at grid level and then DC to DC internal. So there is a lot of opportunity to have optimization on that power network. So whether we want to run it an entire thing on a DC bus or we want to run it on completely on AC bus, there is a lot of flexibility and opportunity to adapt whatever is suitable, which is efficient and easier to do that. Over and above all this, there is an opportunity for getting this energy source from sustainable things like solar, wind, or fuel cells, green energy, green and clean energy. So largely these sources have a DC power source. So I see that there is a lot of opportunity for getting into a DC power network, and that would be more efficient and effective in new modular robotic system. And also maybe at lower voltages, it would be safer to operate and uh, much easier to adapt it. So I see for these things, TE has a lot of opportunity to develop components. It could be connectors, filters, like Ivan was mentioning about passives and EMI, EMC filters and those kind of things. And we are getting ready there to support our customers.
So big question here as we are rounding things out. What can we expect to see or maybe see more of over the next 5 years when it comes to innovation in factory automation?
Well, over the next 5 years, we believe that significant advancements in automation, both factory, hybrid, and process, will take place. And this will be driven by artificial intelligence, sustainability, and the industrial Internet of the Things. So, for instance, the integration of more IIoT devices or industrial Internet of the Things devices will enable a more connected and intelligent manufacturing environments, facilitating seamless data exchange and improving coordinations between machines. And this will support the growth of smart factories where decentralized and flexible production processes can be quickly reconfigured to make or to meet changing demands. The second point, virtualization and digital twins, will further revolutionize manufacturing because they will allow extensive simulation and testing of new configurations at a very affordable cost. And of course, they will minimize risks and costs associated with physical prototypes. And this will enable rapid prototyping and further innovation. And last but not least, sustainability will also be a big focus. With automation technologies improving energy efficiency, as Anil was mentioning, and reducing waste, overall, the next 5 years will see factory automation become more intelligent, flexible, efficient, and having less climate impact in our world.
Just to add upon that, what Ivan was mentioning, it would also be a more safer operations. So it will enable safety becomes critical and it enables safety also.
Great things happening and exciting to see where both of you think things will continue to go in the next couple of years. So basically to be continued. So I want to thank both of our guests today, Dr. Anil Kumar Ramshesh, Fellow Industrial Business Unit at TE Connectivity, and Ivan Ruiz-Dubel, Senior Manager, Global Product Management, Industrial Business Unit for TE Connectivity. Thank you both for being here. Appreciate your time.
Thank you, Michelle.
Thanks a lot, Michelle.
Thank you, Ivan.
And I want to thank all of you for tuning in and listening to the Our Connected World podcast brought to you by TE Connectivity. If you'd like to have more information about what we talked about today or a lot more when it comes to TE Connectivity, you can visit the website te.com. And we encourage you to subscribe to the podcast if you'd like to hear more great conversations like the one you heard today. I'm your host, Michelle Dawn Mooney. We hope to connect with you on another podcast soon.